Problem? That's great. I don't like problems. Well, I like some problems. Maths problems. Okay. Next lesson. Force. So that's a simple title to write down. Force. So we'll start. Force. That's what I said. Okay. Oh, come on, what's wrong? Focus now. I'm talking. So we all understand the word force. I mean, we all have an understanding of this word in English. You know, strong force, weak force, big force, small force. But what exactly is force? So not this, okay? The native speakers at least know what I'm talking about. Yeah? Sorry. Okay. So what exactly is force? So force is what changes the motion of an object. That is, force will change either the direction, the speed, or both. So let me put it to you simply. In other words, force is what makes something accelerate. So if something is accelerated, it's because of a force. So write something down, please. No. What did they ask for the definition of force?
Well, like a force.
What did I say that? No. So really the piece at the end is the key piece here. It is true to say that if an object is accelerated, then a force is being applied. This is the key point here. If an object is accelerating, then a force is being applied. This is critical. Okay, so you can put this in your own words, you can write it all down, but the key thing is still, if it's accelerating, it's because of a force. Okay. 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 How are we doing? Well, look, if you didn't finish writing it down, you can copy it from the video or from someone in your class, okay? But I shall go to the next slide. No. So how do we measure force? So our next question. Well, force is measured in newtons. This is the unit we use, and the letter for newton is N. So a newton of force is the amount of force you need to accelerate 1 kilogram by 1 meter per second squared. So this definition has been on the exam. Oh look, I even say it there. It could be asked in the exam, and it has been asked in the exam. So this is an important definition. Yeah, we'll get to that as well, yeah. Okay, did you write the definition down? So, if you have 1 kilogram and it's accelerated with an acceleration of 1 meter per second squared, then you can say there is 1 Newton of force causing this. So 1 Newton of force for every 1 kilogram accelerating at 1 meter per second squared. And in fact, you have a formula that can let you calculate the force if you know the acceleration. And this is called Newton's second law. And if you're wondering what happens in the first and the third law, we'll look at those in another class. So one way to state this law is just simple. F equals ma. So if you want to calculate the force, it's equal to the mass multiplied by the acceleration. So it's a simple formula, F equals ma. Please note this and put a big box around it, F equals ma. F is the force, m is the mass, and of course a is the acceleration that results from the force. And in fact we can state the laws in other ways too, but for now just F equals ma, and that will do. I do actually want to point out something here with this F equals ma. What's the unit for force? Newton. And for mass? Kilogram. And acceleration? Meter per second squared. So, another way to write 1 Newton is the same as writing 1 kilogram meter per second squared. It's the same thing actually, so you can write both, but it's more convenient to write Newton. Okay, back to the slides here. Right, so here's a simple one here. You have a 45 kilogram girl, and she starts to run with acceleration of 2. So what's the force? What is the force required to get this 45 kilogram girl accelerating with acceleration of 2? Well, that's simple. It's the formula F equals ma, which is 90 newtons. How did you get 90? 45. Yeah, 45 multiplied 2. So I won't even write that down. Okay. Right, so here's another one now. So, what's a barista? What? Come again? A barista. What's a barista? Like a what? No, it's a barrister. Good guess. Good guess, though. Anyone know barista? You met a barista this morning. You met a barista this morning. Oh, you did meet a barista this morning. Well, maybe not. Did anybody go to Starbucks? Yeah. A barista is the person who makes your coffee.
Make the coffee?
Yeah. The person who makes the coffee is the barista.
New word.
New word. Good.
Different types of barista, okay?
Huh?
I did different types of barista.
There's good ones and bad ones.
Like, because there is barista, like, you know.
Barrister has an E-R at the end.
Okay.
Barista? Just an A.
Just a little, okay.
Sounds similar, I know.
Yeah.
Anyway, you have this barista and they slide the coffee cup across the table. So the coffee cup starts at 30 centimeters per second, and then he's touching it for 1 second. And the mass of the coffee cup is 500 grams. How much force did he use in his hands to do this? So look, I'll draw what's happening here. So what you got? Here's the coffee cup, and at the beginning it's at rest, 0 meters per second, and then here is a hand. and the hand slides the coffee cup. And this happens over 1 second, and then, sorry, that's centimeters per second, and then afterwards it's going at 30 centimeters per second. And then, of course, it slides away, but you don't care about that part. So he has the coffee cup, and it's at rest, and then his hand pushes it. So it goes from 0 to 30 centimeters per second. And the question, I said this was for 1 second. Actually, hang on. Okay, so for 1 second would look like this. There's no coffee in it, so it's falling over. But my question is, what's the force his hand is given to the coffee cup? So this question is not as clear because I didn't give you the egg. Oh, I gave you the mass. It says the mass is 500 grams. 500 grams. But I didn't give you the egg. But you can calculate the egg because what did I give you? Well, before that, I gave you U, I gave you V and T. So let's see what we get. U is 0. V is 30 centimeters per second, which is 0.3 meters per second. T is 1, and I'll use V squared equals U squared plus 2AS. So that means 0.3 squared equals 2... Oh wait, I can't use this one. Rats. Wrong one.
You can use A is equal to V minus UOT.
Well, it's not on there. I'll get it. V equals U plus AT? No. S equals?
A is equal to V minus UOT.
Oh yeah, of course, the basic one. The definition, yeah. V equals U plus AT. So I can say that 0.3 equals 0 plus 1T. That was lame. T equals 0.3. No. That should be an A, not a T.
T is 1.
T is 1, yeah. A equals 0.3 meters per second squared. Now we also know the mass is 0.5 kilograms. So F equals MA, which equals 0.5 times 0.3, which is 0.15 newtons. So that's how much force he applied for 1 second. For 1 second he applied 0.15 newtons of force. Which is not much. It's not much at all. Okay. Right, so last example here. You have a 1,200 kilogram car traveling at 100 kilometers per hour on the motorway. The driver suddenly brakes and the car comes suddenly to rest, and the distance is 100 meters. How much force are the brakes applying in order to bring the car to rest? So what you have here, the car is traveling along, and then the person puts their foot on the brake, and the car stops. So yeah, it's going fast, and it slows, and it stops. So what's the verb for slowing down? Decelerate. Yeah, the acceleration is negative. What's making it slow down? The brakes. So my question is, how much force are the brakes applying to the car to bring it to rest? So you have to use the formula F equals MA. Do you know the M?
Yes.
We know the M. Do we know the A? No, we don't know it, but we can get it, because what do I give you in the question? I give you
Distance
U. Yeah, I give you U. What else do I give you?
V, U.
V and F. Yeah, U, V and F. Can you get A? Of course. So I want everybody to try this for me, and then I'll do it. So try it first, please. Let's see if you can do it. Okay, let's have a look at this. So like I just said a moment ago, 1 Newton is 1 kilogram meter per second squared, so really we should be using meters and kilograms for this problem only. Right, let's have a look here. So our car starts here, it's 1200 kilograms and it's going 100 kilometers per hour, and then here it's still 1200 kilograms and now it is at rest. And what's happening here is there is a force slowing the car down, causing it to decelerate. Right, so the U is 100 kilometers per hour. So if I convert that into meters per second, let's see what I get. I got 27.8 roughly meters per second, and here V is 0 meters per second. Oh, I know the S as well as 100 meters. So I can say V squared equals U squared plus 2AS. 0 equals 27.8 squared plus 200A. So my acceleration seems kind of small. What, did anyone else get an acceleration?
Minus 306.
What did you get?
Minus 3.8.
Yeah, that's what I got, but it seems kind of puny. Minus 3.86 roughly meters per second squared.
Yeah.
So finally the force, which is MA, which will be minus 1200 times 3.86. So the answer is quite large. It's minus 46, we'll just round it off, 30 newtons.
30.
Yeah, the nearest whole number.
Excuse me?
Yeah.
U is equal 100 kilometers. Why change it to 27.8
Because I convert it to meters per second.
meter per second?
Yeah.
Yes, okay, but it's 100, we change it to meter per second.
Yeah, I changed 100 kilometers per hour into meters per second.
It's equal 1,000, right?
No. You see, we did this in the first lesson. The lesson which you didn't do the homework for. So, I converted that into meters per second. See, and you're not so sure, right? It's not so clear.
100 kilometers, but I changed it to meter. 100,000.
I recommend you watch that lesson again, and maybe try the homework questions again.
Okay.
Hey, John. Yep, I took it.
Good.
Yeah.
Can you leave it here because I'm in this lesson?
Oh, it's fine. I have to take it now because my one decided not to work today. I think I've gotten my use out of it.
You definitely put a guide on it.
I did, yeah.
Thanks.
No, I'll just...
Assuming that's where it was, and I came to check. So if you leave it there, I'll bring you back to
And you thought, who else could have possibly be using it right now? Yeah.
I couldn't have walked already.
No, yeah, I'll just leave it here on the table, will I? Yeah.
Yeah, I'll be here.
You'll be here at that minute.
Whichever. Bring it back. Like, whatever you feel.
I think I'll bring it back so it doesn't go wobbly.
One working.
Yes, yeah. Okay, so yes, you need to review that. Yeah, because I've done examples of that.
Yeah.
And everybody else is content with that.
Yeah.
Now, why is this force negative?
Because
Because
force is a great
Yeah.
force.
Well, just keep it simple. It's slowing down. So if it's slowing down, the force is going against its motion. Negative. What's wrong with you? What's the problem? You sure? I'm not convinced. Negative because as the car is going forward, it's slowing down, its acceleration is negative, and so its force is negative. I didn't actually say this, but force Is it a scalar or a vector? What do you think?
Vector.
It's a vector, why?
Because you have to.
The following.
No, that's not an explanation. That's not an explanation. No, that's just saying what a vector is. Why is force a vector?
Because it has a direction, like you're acting something towards something.
But this is true, but you're making it complicated. Why is force a vector? What?
It has coordination as well.
Is acceleration a vector? Yes, I told you it was. Yeah? Just like velocity is a vector, and displacement is a vector.
Yeah.
So, if acceleration is a vector, and I multiply it by a scalar, is it still a vector? It is. What happens when you multiply a vector by 2? What happens when you multiply a vector by 2? Magnitude gets doubled.
Yeah.
True?
Yeah.
So, if you multiply a vector by a scalar, is it still a vector?
Yes.
Yes. So, if acceleration is a vector and mass is a scalar, and I multiply them together, it's still a vector. So, MA is a vector. And what does MA equal? So therefore force is a vector. Yeah? That's what I was looking for. Okay. No. Oh, chillax, would you? You have, what is it? I gave you 4 questions in the first lesson, wasn't it? And 5 questions in the second lesson. You have 9 questions for homework. I'll try not to cry myself to sleep, okay? It'll be difficult, but I'll try my best. What time is physics at tomorrow? What time is physics at tomorrow?
That's 6.
Hello.
Great, so you have more than 24 hours. You have 24 hours and 15 minutes. I don't know what the complaints are about. Okay,